over here. Bill Nye, speaking to you from Los Angeles. No, it's not really Los Angeles. Los Angeles isn't covered with miles of ice and snow, at least not now. It was 800 million years ago, but those glaciers have receded, and now Los Angeles is covered with smog and development deals. And the Earth's ice is mostly at the poles, at least for right now. The ice at the poles is melting. Arctic ice melted to a record low in 2002. In Antarctica, ice sheets the size of small states are falling into the sea. The reason? Well, their world, our world, the world, is getting warmer. I mean, is the rise in global temperature a result of the Industrial Revolution, burning fossil fuels and driving everywhere? Or is the rise in temperature just part of the natural ebb and flow of global temperature, and we just happen to find ourselves in the toasty, melty part? Should or even can we do anything about it? Well, yeah, that's the way I see it. To answer the difficult question, is the current rise in global temperature natural or human-made, we have to look back in time. And of course, the details of time travel haven't been figured out yet, so we'll work with what we have. You know, after a few of these, I've seen people lose track of time altogether. But it's not the juniper-flavored ethanol that we seek. No. It's the ice. Now, people say, how do scientists know how cold or warm the world was over the last 100 or 1,000 years? Well, there's a way to find out, and we're here at the National Ice Core Laboratory with Dr. Todd Hinckley. And you're going to show us how we know.
We think we have the information here. We have 15,000 meters of ice, Bill, and we think that our collection here is cool in at least a couple of ways.
Yeah, cool. Yeah, real cool. So, what are we looking at?
Here in this aisle, Bill, you can think of yourself as standing in the middle of the Greenland ice sheet, which is about 2 miles deep from snowtop surface to bedrock. It's been described by one scientist as a 2-mile time machine because there's so much information in the individual layers of ice about what the Earth's atmosphere used to be like and about how hot or cold it used to be on the Earth at the time an individual snow layer fell. This ice has preserved a record of the conditions in the Earth's atmosphere on a yearly basis because in Greenland, the annual layers of snow never melt.
It's like rings on a tree.
It is something like rings in a tree, but our record goes back so much farther than the rings on any tree.
Not 100 years, not 1,000 years, 400,000 years.
In Antarctica, the deepest ice is 400,000 years old.
And here in Greenland,
only 250 here in Greenland.
1,000 years, tube after tube. See, it's cold in there. And here, you know, it's a balmy -7. Dr. Fitzpatrick.
Hey,
Joe.
Bill, come on in. I've got a 22,000-year-old ice core here for you to look at.
This is a piece of ice from Greenland.
This is from central Greenland, yeah.
Now, what do we learn from this?
Well, ice tells you by direct measurement what the composition of the atmosphere was at the time this snow became ice.
And how does it do that?
Well, as the snow grains fall, they trap air in between them, and as they become buried with more and more and more snow...
They seal the bubbles forever.
Absolutely. If you have a bubble in 400,000-year-old ice, you've got a bubble that has 400,000-year-old air in it. You can see bubbles in here, but I have a better way for you to see bubbles on a piece of ice that I've actually cut in this direction out of this core, and I'm going to show it to you right next door.
Oh, let's go next door. So what have we got here?
This is a paper-thin wafer of the ice from that core, and you can see the bubbles in it really, really clearly.
Those white dots are bubbles.
Yep, and what they have in them is a record of the concentration of all of the gases in the atmosphere at the time that snow became ice.
So you can determine, for example, how much CO2, how much carbon dioxide was in the atmosphere.
Precisely how that kind of analysis is done, is to analyze the CO2 inside those bubbles.
So not only then can you get the temperature, but you can also get the composites in the atmosphere all from these...
All from the same piece of ice, and a lot more information as well.
And you have an idea when the last ice age occurred and the one before that, and the one before that, and you're pretty sure that they're accurate, right?
Oh, yeah.
And so you're also pretty sure the world's getting warmer.
Oh, yeah.
It's quite a thing to be in this bitterly cold laboratory and realize
it's getting warmer out there, Bill.
It's getting warmer out there. They say this is the world's tallest thermometer. It's in Baker, California. It goes up to 139 Fahrenheit, 59 Celsius. Now, times are a-changin'. In 30 years, this thermometer may not be big enough.
Gee, Mr. Sanders, why should I worry about too much carbon dioxide in the atmosphere?
You see, Mary and Tommy, in nature, carbon dioxide makes up just 0.03% of the atmosphere.
Wow.
Why would you say wow, Tommy, seeing as you have no reference to determine if that figure is extraordinary or not?
Gee, Mr. Sanders, I sure had not thought of that.
No, you sure had not, Tommy. Children, look at this chart. By the year 2000, carbon dioxide in the atmosphere will have increased by about 30% since the start of the Industrial Revolution. Now, that may not seem like much to you and your punk friends, but it has a profound effect on plant and animal life.
Gee, Mr. Sanders, what was that about our friends?
Nothing, Mary. Now, let's watch another exciting segment of the Eyes of Nye science program.
This is some of the information that we get from ice cores.
So the blue line is temperature.
The blue line is temperature. It tells how much different the temperature has been, higher or lower, from the temperature today at this place in Antarctica where this ice core was drilled. And it goes over a period of 400,000 years.
400,000. So there it's warm, it's cool.
Warm, cool, warm, cool.
We're in a warming period.
We're in a warming period, and I might emphasize it's only in this little blue band here that civilizations and farming have developed. And this time ends at about 1850, before the
Industrial Revolution. So here's temperature. Then what's the red one? The red one is carbon dioxide.
The red line, labeled on the right, is the amount of carbon dioxide that's been present in the atmosphere at any time during this last 400,000 year period.
Time.